else. So I hope I have shared my screen. Ah, I didn't share my screen. All right. Let's share the screen. All right. This is my screen. This is my website. And I will repeat what I was talking about. I will try and use this geometry. And because it has fused teeth, I'll try and remove these teeth, these protrusions, and replace them with these teeth. If it will not be possible for me to remove these protrusions, which act like teeth here, if it will not be possible, the fallback will be that I will take this glove and punch only this, what you see here, because here I am sure about the geometry, about the separated teeth and jaw. So we have the proper things now. Let's see what we can do here. I like this geometry very, very much, only there is a problem with the teeth. It's not an auto-skinned geometry, so we have this kind of facets inherited from the ESTL file that was in the past. Let's hide what I do not care. For example, let's hide these. And I will, these cylinders, don't be afraid, they are there to materialize somehow and axis for rotation. So I'll decide later if I will keep it or not, if I will keep them or not. So here, I see that there is perfect symmetry about this line. You can see here this perfect center line. I can materialize this perfect symmetry with the reference plane, maybe, hopefully. Yeah. Let's, because the plane is perfectly defined by 3 points, let's scope 3 points. And tada, here we have the reference plane. Why am I talking about a reference plane? Because sincerely, I don't want to work on the entire geometry. I will work only on half. It will be easier because I will mirror. In the near future, I will mirror everything. Split body, click a target. I will split this according to this reference. So it says click regions to remove. It's removed. Now we have 1, 2, 3, 4, 5, 6, 7, 8 teeth. All right. What to do in order for them to disappear? What? Sincerely, because I was thinking to use the detach feature, look here. If I'm selecting these, I can right-click detach, and it will kind of separate the selected facets or surfaces. They will be separated from the rest of the surfaces. And the entire geometry will become a shell, a surface. The advantage will be that I can delete these facets when I right-click detach, all right? So what I don't like is the fact that we have too many facets. When I will be removing these facets, for example, this small surface, let's say, it's very complex. Is extremely complex. Even though it's four-sided, in reality, oh my God, the software needs to work so much on this. What is the problem? The problem will be the fact that I will need to kind of fill. Let's suppose that these small facets together with these will disappear, but I will need to fill, there will be a hole. Yes? Let's see if I can kind of simulate a detach command. I will attempt an auto-skin command. Auto-skin command will kind of make such faces, hopefully. Not divided, no faceted, no surface element, let's say. Let's see if it works. If it doesn't work, no problem. So I can convert it or maybe go to shrink wrap if I'm going to shrink wrap, because there is an offset between the original geometry and the new shrink wrapped geometry. There will be a problem with the gap between the. So this is why I will not use shrink wrap here. Yes? Let me explain more in detail. The shrink wrap is doing something like this. And you need to assign an offset. This is the offset, let's say. Yeah? Which is on the contour. The problem will be here because this gap will disappear. Because if I'm going here with the same gap, yeah, it will be here. Then the software will try and mimic this void, this space, and it will go something like this. And it will be absurd. Also here, I don't have space for the gap to maintain this this offset for the shrink wrap. So shrink wrap is not a good solution here. What I will do is very quickly convert this geometry into a mesh. Into a faced body, let's say. Oh, now the problem is, look here. We have, oh my God. Oh, no. So if initially, let me undo. If initially I had around, come on, undo. No, not possible. So if initially I had, let's say, Control A, 4,100 faces. I don't know if you can see it. Look here, 4,000 faces, let's say. These quadrilateral shape, yes. Then if I redo, look here how many faces there will be. 150,000 faces. So not only it's absurd due to the tremendous number, but there will be problems with the mesh. Let me show you. In my eyes, this is a problem. This is a problem. It's a bad interference of misaligned faces, let's say. So also this one, the transition between coarse facets and fine facets. It's translated in English, it's a nightmare what we have now. And in order for you to be 100% convinced, we have these commands. For example, fix sharps. We have 91 protrusions. So if I'm clicking complete, maybe they will be solved, with the exception of a few. And so on. I don't want to click too much because sincerely I will not follow this approach. Let's go just a little more. Yeah, and now we have, for example, 6 areas to solve. Of course, I can solve them, but it will take time, and I don't want to extend this live stream for another 4 or 5 hours. So let's just close this. And just for fun, let's go on GrabCAD because they have free 3D models. And let's write here skull. Maybe we have something decent. You see the teeth are fused here. Fused, so these are STL files. Let me prove to you. Ooh. This looks promising. These are fused teeth. Oh, in the past there weren't so many 3D models with skull, but now there are more nowadays, I see. So I'm looking to have separated teeth out of the box, yes, minimize the work. Alien skull. All right, let's see page 3. What is this? These are fused. Human skull. So this is STL and it's the teeth are fused. This is interesting because we don't have the teeth. This could be something. Let's download the cut part, even though I think I'll not need it. You'll understand in a few seconds. So this is nice. What is this? No, sorry. Unfortunately, oh my god, what is this? I think it's made for 3D printing, I think. Let me download it. I would like to look a little and separate the parts. Yes, yeah. What do we have here? All right. This is with fused teeth. I already know this. I don't remember this one. And this is an OBG. Let's also, definitely they are separate here. This would be nice if this works. Only it says TL. This will mean that there is work to do. We're not scared about working. We're scared about working too much in regards with the live stream, you know. This could be a step file, maybe. Maybe this is a step file. So, I wanted to see the last. Oh, it's a step file. And it's quite hefty, 400 megabytes. Let's open it. It will take some time. Let's open another space claim. It takes 400 megabytes of space because they kept the facets from the STL, from the original scan. They didn't do like a smooth surface, which is a result of auto-skinning in space clean. Look here, auto-skin. This is the command that we need to make smooth surfaces, which this command unites the facets and small surfaces, unites them into bigger surfaces, bigger patches, surface patches, let's say. All right. Let's take it gradually. So on the first view, this looks nice. Oh, and the teeth. Oh my God. Oh, this looks so nice. I remember this. It was a lot of work. Look here. You, at the first impression, you might think that it's one body, but if you right click, you have separate all, and look here, everything separate, all, including the teeth, which is an enormous advantage. Now, if I would like to speed up this live stream, I can select all, right click, convert to solid. This is the easiest way, the quickest way to solve this. But in doing so, the geometry, the solid geometry, will keep these small facets. It will be a nightmare on importing, editing, and solving. And these, another problem is that facets do not allow a certain mesh size. They dictate the mesh shape, the mesh count, the mesh refinement or coarseness. This is the problem with this. This is why expert people always go for auto skin in order to kind of unite these patches and remove all those facets and obtain smooth surfaces. Here it's nice, we have fewer elements, fewer facets, but here we have much more numerous facets. Another problem is the fact that it's, if we can say it's too detailed, it looks too nice. And for example, locating structure 3, do I need this small bone? Sincerely, I don't need it. There are many bones which I'm most convinced they are realistic, but they are not important for our simulation. Locating structure 3. What is this? This is an important bone, but sincerely, we don't need it. These two are also important. Locating structure 3. Let's see if I can delete it. Yes, something like this. It will reduce from the structural stiffness of the upper jaw. Look here, I do already see some problems here. Yeah, let's go at this moment with what we have here. I'm thinking about kind of merging what we have, all these parts. I would like to merge them. Let's look a little on the teeth. Can I select only the teeth? So let's select all these from right to the left. Right click, locating structure 3. Move to new component. I will say upper, we understand it's upper teeth, yes. And let's also select this. Locating structure 3, right click, move to new component, they will be the lower teeth. All right. Why I grouped them? Because now it's easier to hide them, to select them, for example. Look here. I have 4 teeth remained here. Right click, locating structure 3. Let's go with them for lower, just drag and drop. And I have here these 2 teeth, right click, locating structure 3. Let's drag and drop on the upper group, let's say. All right. Let's decide what we do with the rest of the skull. This I can hide. Here, I would like this to be one part. Can I do this? The question is, where do we do it? Do we do it here in the facets or after we attempt to heal the problems? Because I foresee, for example, look here, I foresee there will be some problems with the geometry. All right. There is an operation named merge. 2 selected facet bodies into one single body. Only 2. Let's see if it's possible. Click a target faceted body to merge into this one, another, this one. Mesh is self-intersecting. I don't know if you can see it somewhere. Believe me, it says mesh intersecting. So the conclusion is we have to heal this geometry. And when I am clicking here, 300 protrusions. This is not funny. This is not funny to solve. Let's save it temporarily. This will be geometry 1, let's say. And let's click here. The target is to go towards 0. And now we're in a never-ending circle. Yeah, we have geometry 1. Let's give it a rest for a while. It's the step opened. Yes, the step is opened. And it's... all right. Are they separate? It's the same thing. This could be something. Let me delete what we don't care. The initial cylinders or whatever they were. A not so useful thing is the fact. I think it's the same geometry that I worked on 30 seconds ago. Yes. They did the right-click convert to solid. When this was mesh, right-click, you remember, convert to solid. This is what they did. Which is not too useful, let's say. Yeah, I'm wondering if we have interference here, and the answer will be, of course. All right, so I have, can I minimize this? Let's go on C, desktop. Let's open the CATIA file from 10 minutes ago. So now that I'm checking the interference in this 400 megabytes file, the software is basically froze. So this CATIA file, no, this CATIA file, no, it doesn't work. Do I have CATIA installed? Let's see. Oh, I have it. Let's see if it's possible to open the geometry. If the teeth are separate, then we have a good thing. If not, let's see, right click, separate all. Ooh, the teeth are separate, only they don't have roots. And I kind of wanted to have roots. It's such a nice geometry, but they don't have roots. Do we stay with these or not? These ones or not? I will remember the word kurukafa. Where is Katya? No Katya. We see Katya here now. I will close the checking of intersection because I know from experience it's a tremendous work and it's a nightmare to edit. And sincerely, I don't want to lose my audience, big audience made of 0 people. I don't want to lose you. So, where were we? Kafa. I think I already opened this. No, it has fused teeth. Let's delete this. The Katya file didn't open. Let's see if I have something else to open the Katya file. Ah, no, another space claim. Well, let's try with Inspire. If not, we have Discovery 2025. Maybe there we can open the Katya file. All right, so feel free to skip ahead if you don't want to stick to the geometry side, to the modeling side of this live stream. Modeling and yeah, searching for a proper geometry. Come on, open. Until then, we have another Katya. Let's see if I can open this one. This works, yes. And here I would like to bring the one that occupies less, this one, to see if Inspire will open this. Discovery opened. Yeah, 300 megabytes, and time is needed. So it didn't do anything, this seems solid. Let's see if Discovery will do something. I think something is fishy here with this cut part. Yeah. Let's see what gives here, and open another space claim. Why not? I would like to see maybe this skull, or its fused one. This looks promising. Oh, this looks promising. I like the very few amount of faces here. It's already simplified, let's say, and let's delete the few amount of teeth that I have here. And maybe bring our own teeth here. There are no interfering bodies. Is it the case? It looks. It's too good to be true. It's a. It was too good to be true. How do I separate this? So these Katia parts are a bust for me. Maybe I should have, I don't know, a more recent version of Katia, and I don't have it. So I was here. How do I split it? Split it or not? Before going further, let's meditate a little more on what we have. No, not useful. What was Guru Kapha? Let's see again. It was the one with the no roots for the teeth. Separate all. Yeah, I remember, no roots for the teeth, which is not very useful for us. All right, so again, let's see what we have here. And I remember that I needed to have all the teeth. I needed this simulation. All right. So yes, sorry for the waiting, for the future audience, of course, not for the present audience. Oh, we have one viewer. We're very far away. Yeah, let's delete these faces and we will see what will happen. there is also this possibility of deleting more. All right, so from the right to the left, come on. What do we need? Ah, shift. I was pressing control. Let's right click detach, and you'll see what I was talking about 15 minutes ago. Come on, detach. It froze. What? Let's open another space claim because this doesn't work at this moment. Oh. So I will be selecting the teeth, let's say, delete them. Also from here, normally I will do something like this. The problem is we will have some cavities, and who is going to cover? Is not cavities, we have some holes, let's say. How are we going to fill those holes? Oh my god, oh my god. I will admit that I'm in a pickle here with these teeth. Maybe it's more than I bite. You'll not believe, but this is the skull. So I kind of converted the skull into surface in order to remove some fused teeth, because we need separate teeth, individual teeth. Oh my god, what is this? At a certain point, I will need to draw a conclusion of giving up this geometry and this approach. For me, too complicated and confusing, why not? Let's attempt a healing, even though I think it's absurd. So we have repair and we have missing faces. 7 missing faces. No, I don't think they will be joined. But we can really hope. You are seeing now a method, an approach regarding some unwanted features and how to remove them. And heal back, correct the original geometry. Hopefully, but no, the holes are too complex to be filled. Yeah. So undo. Let's look back at what we can use that was already, let's say, used or kind of verified, let's say. I'm looking for a jaw which doesn't have teeth. Unfortunately, we have industrial jaw, let's say. This could be nice if the teeth were all right, but from what I remember, the teeth were not right. There were round teeth, if I remember, without roots. Yeah, let's download it and verify. What is this? Let's see, what is this? I've opened it in the past. The geometry is so good. Yeah, right-click, separate all, and let's look at we have a tendency of roots. Yeah, you know what? Let's stay with this. Finally, let's stay with this because even though it doesn't have proper molars with multiple roots or something, let's stay with this. Yeah, let's not transform this live stream into a pitiful circus. Let's stay with this. Yes, here from GrabCAD, I have seen something like a fist. This one. No matter what I searched, this one was the best. There is some work here because it is ETL. But as I said in the past, we don't shy from work. So this is an STL. Let's hide the other thing. Let's see the problems. Facets and 11 protrusions. Oh, this could be solvable. Perfect. Now, if we're going for tools, auto skin, we'd like to remove, as I said, the facets and have smooth contour, smooth boundary condition. Smooth boundary on the geometry. Where is the problem? The problem is let's hide the original facet body, and this is the problem. Now, if we are going for repair missing faces, it will be what exceeds 4 sides. It's very, very hard for the software to remove it. But I think if I remove this, I think there is a better chance. Missing faces. Do we dare to hope that it will be filled? No, we don't dare. Because of these irregularities. Look here how folded it's this surface. What we can do is we can kind of cut it. Look here. I will choose a point and make a plane through that point. I will go for move, then rotate here and bring it down, something like this. We don't care about precision. All right. Now what I will do is split body. Split this body with this plane and remove the top portion. Now what I can hope is maybe to fill this hole if possible. This big hole, yeah? Let's see. We don't have irregularities. Let's hope. Oh, yes, let's leave it like this. We have a fist. Now, where are we? Inverse visibility. Sincerely, I don't care about these faceted bodies right now. What I care is to make these, to skin these, because they are still faceted parts. Yeah, originally being STL. Let's go here, Tools, Auto Skin. Here, Control A. Can we hope to auto skin everyone, each and everyone? Let's see. Any question from the audience? Hi, Himsho. If you have questions or something regarding mainly structural, I can answer, and I can hopefully be of some assistance and help. So, be my guest, please. It's such a nice geometry, so well done, so smooth. So, even though it's faceted, we can hope to auto skim and use it further on. So I would like to save this into a folder named ANSYS 2023 R1 2026 and so on. What is the naming? Stream 24. Okay. I will call it fist punching teeth. And yeah, let's hope it will work. Why I opened another geometry is because I would like to use some of the materials. We have some bones here, normal, escape pores, if possible. So, there are some problems. The auto skim didn't work because there are some problems here. What we can do is go to facets, fix sharps, and there are, oh my god, 145. Let's save this. Right click, source, internalize all, save as, geometry 1, yes. Now let's go for heel. $33 is the minimum. They are interfering, if I understand correctly. Let's see where is the problem. Here is the problem. With those small faults or whatever. can somehow pretend that I don't care and maybe delete all these depressions, cavities, whatever. It's not the stomatological cavities, it's the cutouts, let's say. For fun, can I delete this? Just asking. Oh my god. Oh my god. Oh, whoa, 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 whoa. Oh, self-intersecting. So let's go with undo, because there is a special operation called this one, over connected intersection. Detect and fix self-intersections. Come on. Yeah, so. All right, and now we're going for fixed sharps, 85. I don't know what to do right now because the options branch now. Should I heal now or later? Geometry 2. So let's try and heal with this. I hear that now we created other self-intersections. Let's go here, self-intersections. We don't have self-intersections. All right. We are a little better. My question is if I can delete this. Let's see if I can. Oh, what do we have here? Oh my god, oh my god. Just for fun, can I delete something like this? Oh, there were some pockets inside. Oh my god. Oh my god. Oh my god. What do we do? I know what we can do. I know what we can do. Oh, it's such an easy solution. I can shrink wrap it. Let's find out, let's have a feeling about the gap. For example, the size of this is 0.08 millimeters. Let's make a shrink wrap with an offset of 0. Why 0.1? No, 0.2. Keep original bodies. Yes, we don't need precisions. We don't need precision in our modeling point. Ooh, it looks so nice. Look here, when I'm searching for error, there are no errors now. All right, so let's show Let's show everything. Now, there is a problem with the fact that we have interferences, but that's a thing for the past. Let's go for AutoScan. For the future, that's a thing for the future. I will solve the interferences between the teeth in the next steps. We cannot finalize the AutoScan operation if we have errors in the faceted bodies. If we cannot solve the errors with this tab, with the facets command, we cannot finalize the AutoScan. I was asking for a question. There is no question. All right. So feel free to ask any question regarding to the topic or the FEA or biomechanics, and if I know the answer, or I can point you, at least I can point you in the right direction. Be sure of this. So you see, it grouped, the software grouped the small facets into patches, into bigger patches, let's say. And it's trying to unite those patches into a surface body. Then it's trying to solidify, to fill the surface bodies, because there will be multiple surface bodies. They will be filled in order to become solid parts in the end. It's grouping gradually from clusters of facets into patches. Then it unites the patches in order to obtain bigger surfaces, which will then be welded or sewn, let's say, into a final surface body, which in the end will be kind of solidified into a solid part. Yeah, and this is done for all the parts, hopefully with success. This is the part, the geometry, the healing, the correction that chases away many students, researchers, engineers in biomechanics. It's so complex, and you need to be very creative and to come up with so many ideas. So what do we have? The parts that were successfully solidified, let's say, they remained as facets. There is one tooth and the upper jaw, the skull. Let's hide others and see here. What is the problem here? There is a problem. All right, because at this moment I don't see the problem, we have the repair. The repair solves, the repair tab solves the problems with the surface bodies. Usually there are missing faces, 5 missing faces. Let's see what can be done. This can be done easily. Also this. I have my doubts here because there are so many sides. Let's see if it works. Yeah, we do have some deviations. All right, and the last one is this one. Is it big or not? No, it's neglectable. Oh, yes, we're in luck. So we have another, let's save this. Right-click source internal as well, in order not to be dependent on a past version. And here we have a missing face here. Let's kind of delete and make way for this to be filled. Repair missing face. Yes, now it's solid. We have everything we need. I don't care about these face body anymore because I think we have all the parts. Yes. Gradually, let's position the fist towards the skull assembly, and we will kind of resize. I would like to rotate these something like this to take the full impact, something like this. And let's see which size is more correct. Either the skull or the fist, one of them is wrong. Because it should be the opposite. The fist should be smaller than the skull, of course. Let's also reorient something, maybe something like this. I don't know at this moment how the impact will occur. All right, I was promising you a measurement. So 250 millimeters around. Let's take a distance between this point and this point, for example. 47 millimeters, which is absurd. Let's scale all these parts 5 times. We are selecting an anchor point, then we select all these 5 times. All right, let's see the fist. What is doing now? The fist is too small. It's very easy to scale it to. Pick an anchor point. We don't care too much. This one. It's kind of this size. So let's do it something like this too. All right. Now, usually there is no absolutely horizontal and rectilinear trajectory for the punch. Usually there is something inclined, there is a curve or something in the trajectory of the punch. So there is a right cross, if I understand correctly. which is this one is the frontal one, right cross. Right cross. So let's go with the right cross, yes? I don't know if this right cross will extract some of the teeth. In order to ensure extraction, let's go a little lower here and facilitate, the extraction of the teeth. Now, I'm thinking what will happen with this jaw. All right. By the way, I kind of let's name this fist and get it out. All right, I can delete this now. This is a lower jaw. And which one is the skull? This is the skull. These are, of course, teeth. Can I select them? If we categorize the teeth very well, then we will complement ourselves in the future. So let's move them to upper. They were the lower teeth. And the rest is the sub-assembly named upper teeth. Move to new assembly, upper. All right, why I'm doing this? Because I would like to solve some of the interferences. They will look a little roughed up after solving interferences. But I will not take time to distance themselves. Let's let them be. Where is the problem? Besides doing the same thing for the lower jaw, the problem is that these teeth will impact also the lower teeth. So we'll need to perform another interference command, let's say. So everything is perfect here. Let's hide them. All right. Let's check for interference here. So remember, you can skip ahead if you don't want to stay for the modeling stage. Nobody's forcing you. Because we do have this interference between the upper and the lower teeth, I'm thinking about making a sub-assembly between the jaw and the lower teeth and move this downwards. Can I call it mandible? I think I can call it, yeah, mandible. Maxilla. Maxilla is up and mandible is down. Okay. So I'll make a sub-assembly called mandible. And this one will be called skull, why not? And it will have the upper teeth. Come on. show us the interfering regions. Yes, we need not to for test, 1 second. So for the lower, let's move the jaw here. And let's move the skull to upper if possible. Yes. So I would like to move this one lower because it removes some of the interferences from here. Design, move. Yes, something like this. Yeah. Can I move it even a little more? Even though there will be some interference. Here we have an interference. What? No, there is no interference. What was I talking about? Gap. All right. So let's test something. So I will remove the interferences, the collisions from the bigger body, which is the mandible. I'll take a look on my smartphone, a few seconds. Yeah, no message. Come on. So, because this option is empty or unchecked, the subtraction will be from the larger body. Yeah. So let's do something like this. Then we're going to use a section view to cut through the tooth and mandible and see if the cutout is properly made. We need to be very neat and with a great deal of preparedness when doing such modeling. The fact that I have done the sub-assemblies and kind of divided the work, it's very important in order to have a clear perspective, not only for you, but also for me as a practitioner of what I'm doing here. So it's always a good thing to be very correct, neat, give namings, divide the work, the stages, the approach, and you'll congratulate yourself in the future. For you, and also while you are working for others. If somehow is working in a messy manner with a chaotic approach, then that person will have troubles with his or her own simulations. And also there will be a nightmare for others to edit, to open, and to assess and redo those simulations. So it pays off to be very consistent and pay attention and be very neat with a very clear approach. In a company, in a hospital, or whatever establishment, most of the work that we're doing is temporary, the project is temporary, the job is temporary, and we need to leave space for others to continue our work. So let's see about having a plane. Look here, this plane is good, section. And we have what we needed. Yeah, this is a proper cutout. Let's do the same for the upper interference. In this field, in biomechanics, due to the complex geometries, very few people attempt and approach it correctly. There are some people with primitive approaches, let's say, yeah. But doing a great job is very hard in this domain. Look here, where was I here? Yeah. For example, heart, for example. I will not be talking about artistic approach, but just try and understand that it's not easy to find a good heart geometry. No, this is too difficult. Let's go for a bone. Femur, which one uses? There are people trying to model the femur in a very primitive way. Let's see if I can see this primitive approach. Here, it's not good. I use the wrong example, but there are people, maybe this one. Yeah, look here, this is the femur. So it's, yeah, sad. As I said also in the past, I also take my 3D models from here. Yes, and even though this model is not correct, it doesn't have the proper roots. Look here, these teeth have the proper roots, and I am also buying. It's not so expensive, $5, and there is always discount. So imagine, look here, how nice they look like. Not only teeth, yes, I don't know, tibia. Look here, only 24. If you're on the cheap side, $5. So there is only $20. Look here, and it looks so nice. Let me see if I can see the mesh. Yeah. Oh my God. Let me add to cart. It looks so nice. And I think you can also kind of negotiate the price, I think. There is also message, and maybe while messaging you can kind of negotiate the price. Let me log in and see. I'd like to see if there is an option for negotiation to the email address. Do I want to access the email address? No. All right, so it's CG Trader, remember, yes? We have this one. I have solved the interferences. Right-click, show all. Now, if I am correct, of course there is no interference with the fees. Let me hide the fees. There are no interferences here. I would like to see if here, no, there is no interference. And the final check, always remember to make like a final check and check for interference in the entire assembly. I would like to open a simulation, a past simulation from a live stream, because maybe we have better bone materials. I promised in the beginning of this live stream that I will be talking about biomechanical materials. Let me look a little here. I remember working offline after I have closed this, and I remember assigning better properties. So nothing nonlinear. Only linear materials here. I have a nonlinear bone with bilinear isotropic hardening defined here. I think I will stick with this. Can I export it, or do I already have it? No, I already have it. Normal bone. All right. So I'm thinking what to do with this mandible, because at this moment it's not very well bonded or welded or fused with the skull, and maybe I will assign like a bonded contact, and assign a limit for breaking the contact. So let's go here for AI and ask for average breaking stress of, but it's not of bone, in reality it's for ligaments. From 5 to 100 megapascals, of course. Yeah, let's use something like, I don't know, 40 megapascals. You will see in a few minutes. So let's drag and drop an Explicit dynamics and insist on the nonlinear bone. Or not. And here I can import the nonlinear bone. I think I will use the same for the fist, the same material. Yeah, for simpler approach. This is what we're looking for. There are no interfering bodies in the model. This means now we're fully prepared for FEA. Also, just for fun, we have this one, yes. The tooth in the maxilla, the fist, the tooth in the mandible. Always remember to check and double check and triple check. Yes, save, and I am going to copy this. Right click, import geometry model. Let's go on desktop and name it what? Fist punching teeth V1. Let's copy paste this. I will insert here the name, then I will cut the file from here, Control X to J, Control V, and open it here. All right, so save. Double click. I can close Space Clean. Any question from the large audience? Hey, thanks again for your amazing videos. Thank you for the remark, Mr. Prasad. Thank you. It helps with the boost. It gives me a reason to continue. You know, every good remark helps everyone. So the geometry is being opened now. While it is being opened, let's ask here for an average boxing punch speed. Maybe 15, 20 miles per hour. This means 9 to 11 meters per second. By comparison, an untrained average person is 6.7. Yeah, let's go for 11 meters per second. Oh, even 14. Why? Because having a higher speed, it allows us to have a shorter ending time. This is why we need a higher speed. When you move slower, then you need a bigger end time to to solve the simulation, let's say. What's new in mechanical? What is new? Very quickly, the materials are lower is lower. All right, upper is upper. Let's assign the materials. Normal bone. All right. Even though the teeth, at least the teeth should be stiffer. Teeth nonlinear. All right. So let's go for isotropic elasticity for teeth. What do they advise? We have to do something in the middle. This is the harder coating, pulp, yeah, blah, blah, blah. Let's go with 0.31 and 50 gigapascals. .31, I said. .50 gigapascals. Density, do we have density? Can you advise density for teeth? Enamel dentin. Let's go with 2400, which is something in between. Here, this will be cortical bone 2000. Can I be even more daring and ask for tropic hardening for teeth? Let's see if it's possible. Logical error in FEA. Hardening represents classic ductile plasticity where material yields, and so natural tooth components are highly brittle. They do not exhibit a plastic hardening curve. However, if you're modeling dental implants, it's highly relevant. All right. Instead, it advises me to go for more Colombo Drucker-Prager. More Colombo for teeth. Oh, yes. So it says we're going for dentin, something like this. Tensile strength and compressive strength. Never use standard for missing-equivalence stress. All right. Do you need help converting your UTS into specific cohesion and friction angle? For fun, all right, you convinced me. We're not going for linear isotropic. But I think we have here failure. Do we have more Coulomb? I don't see more Coulomb. Brittle granular. Ah. We have Drucker-Prager, but I'm afraid that this is for soil, I'm afraid, for rocks. Drucker-Prager strength linear. In ANSYS, I can easily insert Drucker-Prager strength linear. Can you advise some values for teeth? Let's see if I'm correct. Drucker-Prager strength linear. All right. Can you advise some values for teeth? Let's see if it's correct, if it's not forced one. One configure an ANSYS so to yield stress and slope. Yes, usual values. Yeah, let's see if it's possible. We have yield stress, perfect. The yield stress at zero pressure, if using what Pascal? If using Pascal's, let's copy this value if possible. It's not possible. 2.3 at the power of 7. All right, and the slope is 68. It's not 69. Come on. This is for enamel, and I said I will go more for dentin. Let's make it something in between, you know. We need to make like an average mean. Let's make here 5 at the power of 8. 5 at the power of 8. And the slope is something in between 70 and 53. Let's make it 60. 60. Oh, yes, we're learning. Yeah, let's go with this. Is it perfect? I don't know if it's perfect, but we'll leave the detail and accuracy for the researchers on this matter. We're going to perform a simple simulation right now. Let's save this. And what is this? Mesh quality worksheet. Come on. leave me alone. Right click generate mesh. After we make capture curvature, no. And quality, let's make it smoothing low. Mesh quality, we don't care about mesh quality at this point. Target aspect ratio, all right. Right click generate mesh. Let's see the default. Perfect. Let me remember two. These are teeth. And let me remember to assign the proper material for the teeth. Teeth, instead of NL, I will call them DP from Drucker-Prager. All right. Also, these teeth will be called refresh materials. Teeth Drucker-Prager. Teeth Drucker-Prager. All right. Lower, everything is nonlinear bone, nonlinear. We don't care at this moment. We do have this mesh. Is this nice? It looks awesome because we don't have the facets. The original facets, if you remember from 1 hour ago, from half an hour ago, from the original STL file we have. Now we can control and refine all this. So why don't we have the units in millimeters? And I was thinking about an element size, I don't know, maybe 5 millimeters. Maybe 10, and I will refine further on. It's nice for now. Now the problems begin. All right, 12,000 nodes. Can I make this 8? Let's make it even 7. What is the node count for the skull? Because I don't care about the skull. 25,000 nodes. No, I don't care about this. So let's go with the sizing. This and this will be 10. This can be 7. And the teeth, let's make them maybe 5. I can see kind of few teeth. 1, 2, 3, 4, 5, 6, 7. Yeah, there are some missing teeth, I think. Yes. Let's see the node count for the skull, for which the skull is not an important part in this simulation. So these are teeth. Let's make these 4. I don't want the skull to look so awful. Mandible, and these are the teeth. Yes. I would like to make a section view to see how are the teeth embedded in their respective bones. Home, section plane. I'd like to see if I have a proper socket. Look here. This is not a proper socket. Yeah, the skull bone, the maxilla interferes with the tooth. So this is not a proper meshing. Here it's kind of, let's say, better, even though there is an interference. So this calls for some mesh refinement, but only in the area, in the zones where we have teeth. I think I can move this real time and understand. Look here, it's not. This is awful. This can work, but upwards it's awful. This can work. Let's refine upwards. How do we do it? Look here. We will assign a sphere of influence. Let's isolate only this. We will assign a sphere of influence. Coordinate system. We do have something. Create. All right. Let's create a coordinate system which will use as a reference the global coordinate system that we already see now. The difference will be that this is editable. I can offset this. Or not. Why it's not possible? We don't care. Control F to select a face. I will select this face. And let me bring this down. Coordinate system, and we have offset. About y-axis, how much? Let's make -100. Something like this. All right, also after -z, -40 maybe. Yeah, and I'd like to have like a refinement here on this round zone which encompasses the roots, let's say. You'll understand in the next seconds. Sizing, Control B to select the skull. And I will assign here, I don't know how much for. Yeah, we have the teeth for 4, yes. Also 4. This will be for the skull. And assign sphere of influence the second coordinate system. Sphere radius, how much should be the radius here? Maybe around 200. Yeah, something like this. only instead of 200, maybe 150, 120, something like this. Oh yes, it looks so nice. And hopefully we can refine those cutouts. I'll not say cavities because cavities are stomatologically specific, let's say. I will say cutouts here. Now, generate mesh. It will refine the mesh here. And we will go again in section view and see how the upper teeth mate with these cutouts from the skull. Let's see. Look here, how nice it looks. Yes. Now there is no more awful interference. For next tooth, look here. Yeah. So we solved this problem using this sphere of influence. If I want, I can also make a slightly finer mesh here on the mandible. Instead of 7, let's make it 6. Not because the mandible doesn't have so many nodes. 1,300. Now we can go towards 2,000, no problem. This is the skull or the maxilla side. Let's see. Fist is fist. We have renamed everything. So now it kind of properly mates what we have there, even though, yeah, it's good. I'd like to have a faster solving time. This is why I don't want to go too much too higher with the node count. Let's save this, and if we have a question from there. Yeah. Mr. Prasad, can you please tell me where I can learn mesh techniques? Most of the time I achieve my defined mesh criteria like aspect ratio and everything, but my max aspect ratio is always high. There is in the help of the ANSYS documentation. There is. And in principle, you need to take into account or to use all the options regarding the mesh sizing, mapping, matching, refinement. Yeah, so it's not the purpose of my live streams, because doing a very good mesh is not only, it will be very time consuming, and it will be pretty boring for some of my audience. Not that my audience exceeds at this moment 1 person. But yeah, I know what people want. And people want results, want breaking and something. So yeah, go for the documentation. Average is under limit, but maximum always, yes, this is Mesh Kitchen, and sincerely, I don't want to discuss it in the live streams. It should be, there should be values specific to each laboratory, team, whatever. And be sure that you need it, okay? If you're a professional, you will surely need it. You surely need what the team asks of you. If you are just a student or a beginner, don't care too much at this moment. Go for the physics in principle for the simulation. This is my opinion. Don't make your life hard if you're a beginner. So let's assign here an average velocity, which, if I remember correctly, someone said to be we were advised to be how much? Ah, 0.1 second, 0.05. Let's assign 0.05 and 40 meters per second. 14 meters per second. Yes, and the end time should be 0.05. 1e minus 6. Let's advise some time steps. 1e minus 6, I said. Minimum time step. Mass scaling, no, because we have nonlinear materials. Here, geometric strain limit. Let's see what they advise. Maybe they will say something like 1.2, 1.3. No. Oh my God. Come on, we're not going with shards of broken enamel. Let's not exaggerate. Let's go here with 1.2. No inertia of eroded material, 100 number of points. Yes, let's go for the... We do have an overall body interaction friction S. I'd like for these teeth rename based on definition. I would like to delete the contact that are pertaining to the mandible to skull. This is important for us. I'd like not to have the fist. Where is the fist? Teeth to fist. All right. I would like to suppress this. We do have this contact, and as I told you in the past, I would like to have it bonded but breakable, and there is a hefty gap here. This gap is around 2 millimeters. This means I would like to have this offset. I don't know how much. 2, and make it breakable. And I remember there was an advice regarding the stress. For ligament. I was asking for the breaking stress for ligament. I don't know what to say. Let's make it 30. 30 megapascals, and for shear, half. enough of it. 60%. All right, 18 megapascals. So we will pretend that there is something holding here, only on this point. I would like to have everything. I would like not to have teeth-to-teeth contacts, not to be bonded, to be more exactly, more accurate. Oh my God. So much work. Right-click suppress. We can also delete them. Let's delete them. I don't want this to be cluttered here. Teeth to teeth. I don't want this. Mandible, yes. I'm looking for teeth to teeth if they exist. Yes, here. Yes, this is what they have inside, the contact inside. And all these contacts, except mandible to skull, yes, all these contacts, except mandible to skull, I would like to have them let's assign here, I don't know, maybe 0.25. Because there are irregularities when the roots they are mating with the cutout in the bone. I'm talking here about the mandible, but also it's the same for the maxilla. We need to, you have seen in section view that there are some gaps. And I need to take into account these gaps. Look here, for example. Not exactly here. Look here. There are some gaps and some interfaces, and I would like to take these into account by assigning an offset, you know. Let's remove mandible and skull, and this is the reason for my 0.25. Should I make 0.5? Why not? Let's make this breakable and go for how much should be the so it's the I'm talking about the PLA, I think, or periodontal ligament. Periodontal ligament. This is kind of what is holding the tooth, and I kind of want to see the breaking stress for periodontal ligament. I think it would be much lower. I don't know, 510. Oh, 4. If it would exist, but it's not. We're only assigning a theoretical stress, some theoretical stress criteria. So how much should we make it? 2.5. Let's go with 2.5. It's somewhere in the middle. 2.5 and 60% of this is 1 point, I don't know, 3, something like 1.3 megapascals. So we have assigned the possibility of them to break out. Yeah, as I said, knocking out some teeth. Let's see. Let's hit solve. And let's ask for deformation, velocity, stress and strain. To have plastic strain also. Save and let's see how long it will take. Short calculation. So the distance that needs to be traveled is, let's say, kind of this distance. It's, let's assume it's 70 millimeters. And we know the velocity. We do have, because this is the space over time, we do have like an idea of the ended time, yes? So time is distance over velocity. The distance is 70 millimeters over 14,000 millimeters per second. 14,000 millimeters per second. And separately I can write 70 millimeter over 14,000 millimeters per second, which goes upwards. Then we can simplify like this and cut something like this. And the 7 with the 14 is 2. So here we have 200. So the time is 1 over 200 seconds. And 1 over 200 is, I said 1 over 200 is 0.005. This is what we need to have in FEA, even though they kind of suggested 0.05. We have it even faster because we have a zoom in. They said 0.05, I think, beginning with the moment when the punch launches until it finishes the travel from the attacker to the victim, let's say 0.05. Let's go with this and see. Let's have a feeling how, for the FEA, how long it takes. Always make such calculations and get a feeling about the end time and the other details. So nice. I think it will work, I think. Yes. sometime in the near future. Come on. Yes, it works. "22 minutes. I was wondering if mass scaling helps. Yeah, let's see what will happen. Thanks for the reply. I am just going to take it. Take it easy. Prasad, it's perfect. Take it easy. Just enjoy FEA, at least for me. I would like to see the process, the movement, the breaking, even after almost 25 years of FEA. So don't stay in the mesh. Your meshing will be done by your company, by the team that you'll work there. So don't specialize too much, because meshing, let's face it, is not so fun. I worked in Patran and I was doing hand by hand each contact element. I'm talking each beam in the contact by hand, node to node. So it's not so fun. Go for the funny stuff. Then, after you have caught the microbe, then you can do stuff. You know what I'm doing now. For example, the hours that I'm spending with the modeling. Is it so fun? It's not so fun. What is fun is to have results and everything to move. This is fun. Look here. Yeah, it begins to touch, and yes, something will happen. This is fun. You are in the beginning stage. Be attracted by the fun stuff. Meshing is not so fun. It's useful. This is how it should be done. We should have quality in our meshing to have reliable results, but it's not for beginners. So only if you think you'll have an advantage for hiring, for interviewing and testing. If you want to gain an advantage against other candidates, yes, you can explore the meshing, but I would advise a beginner to understand the software, the phenomenon. This is my advice. I think I already learned some basics, so I want to move towards advanced. Any career advice, really appreciate. I am currently a FEA engineer, so I'm just graduate, and you're an FEA engineer already. Yes, I don't understand how, but yes, any career advice, really appreciate it. Why do you need advice if you're an FEA engineer? At home or you are hired? Also done a CFD trainee in Volvo. Okay. You need to kind of establish where do you want to go, either for FEA, talking about structure, or towards CFD. 1 year for CFD, yes, this means that you should be very advanced now. I think maybe you took an internship for with Volvo. Go for there if you like the field. Personally, I'm not feeling so attracted towards CFD. I'm more of an FEA guy, and you already know what is to be done. So competition, I think it's fierce in the presume you are in India. So my advice for you, if I have an advice for your career, do what I'm doing. Make a portfolio online, create a YouTube channel, and publish some of your FEA. Even 10 simulations if you have them, and they do not need to be extraordinary. Okay, even 10 simulations, they will give you a plus on an interview. So start from something and show. And always mention that YouTube channel in your mail or in your CV or resume. Mention your YouTube channel. And it should be something decent. Don't post on that YouTube channel League of Legends, Counter-Strike, or Dota, Overwatch, or what games, Minecraft. Only post the YouTube videos, the FEA clips, and watch out for grave mistakes. Yes, if you are doing a bearing, which I doubt, don't because it's very advanced. Don't have bonded contacts. If you're doing gears, also don't have no separation contacts. Don't chew, don't bite too much. Okay, so take it easy. Do what I have done since so many years. Go on GrabCAD and take some small assemblies. Small assemblies. The bigger the assembly, the more numerous the parts that you will have, the problems will amplify so much. And if you are a beginner, you will not know what to do, how to solve them. Yeah. Just imagine that 90% of my live streams, for example, almost all of the live streams are made with geometries that I have just seen, and you can see the struggle that I put, and it's not so funny. So, and I have years of experience. So take it easy, verify your geometry, your assemblies to not have interferences, and make some simulations. Or with CFD, it's even easier if you like CFD. So yes. But if you like CFD, normally you shouldn't be so glued to my YouTube channel. You should follow CFD engineers, not me specifically. This is my advice, yes. I'm not a treasure of CFD knowledge. Oh, look here, what do I have? It's pretty cute. I would like to kind of stop it here. It's a nice start. I'd like to stop the FEA here. Because it's kind of too much. I would like to, sincerely, I would like to increase the breaking stress limit, let's say. So let's pause it. So Prasad, good luck. Yes, so do something more. Have an advantage. I'm saying this to everyone. Have an advantage in your career. Your career is serious stuff. You have finished faculty. No more exclusive fun. So you need to think about your future. And how do you ensure a better future? Populate your CV, your resume with real stuff and with the experience. If you already finished it, engage in something more, other grants or mastership, or I don't know. I don't know if PhD now. I would advise to go for PhD now because you are wasting precious years. You are young. You should gain experience. You should specialize. This is my advice for an FEA career. Yeah, so make projects, make a portfolio on YouTube. Our work, the simulation work, is very well suited for YouTube because it's animation. So show show what you are doing. Don't stay, don't waste. It's normal at this age to be absorbed by, I don't know what games there are now. PUBG or similar stuff. It's normal to be absorbed, but remember about your future. And now you're defining your future. You need to earn your living, to earn your existence, to support yourself and also your beloved others, starting with parents, brothers, and maybe considering in the recent future to support your future wife and your future children. So yeah, begin to think about your future. So I said about, let's go for mega. Why it's moving towards meters? I said 2.5, 1.3. Let's go with, I don't know. 10 with 6 again. 10 with 6. And maybe the teeth will not fly away so much. I think maybe I also exaggerated a little with the velocity. Let's make it not so much, all right. 0.0. Do we keep 0.05? 0.05. Let's minus 12 meters per second and solve. Okay, maybe you already left the chat, but the advice is for everyone. Ah, 0 audience. Yeah, I'm talking to myself. No problem. It's the intention that counts. So I want to make an announcement of the fact that in a very short time, in the next weeks, I will publish on my Patreon account these files. I'm talking about the geometry and my trials. They will be present on my Patreon account, and yes, together with some other simulations from my website. So who wants to initiate themselves more in this field of simulations, they will have the opportunity, because on Patreon I will make like a repository which will be very accessible for customers, for my subscribers, let's say. So I will publish on my Patreon account the webinars, their simulation files, their geometries, and also for the live streams, their geometries and the simulation files. And also I will include such packs. We do have packs here, Sophia packs, and there'll be in addition, each month there will be different packs available for my Patreon subscribers. So only here, for example, if this pack, some of these packs in principle, they are valued at around $180. And simulations multiplied with $18, average price. On Patreon, for a subscription of, I don't know, $15, $20, $30, you can get some of these packs, one or two. I will need to adjust the price, but it is a very cheap alternative solution for the people who want to dive deeper into the simulation field. We'll be approaching the end of this simulation, and my goal for now will be to not have the teeth fly away so rapidly. Let's see if it's doable. Yes, let's go for the biomechanics. ANSYS teeth, for example. Let's see what other people have done so we can learn from them. Medical implant fatigue simulation. This is not so biomechanical. ANSYS gear. Contact. Look here. If I see correctly, this is bonded contact. How can we have bonded gears? How is it possible? This looks like artificial intelligence here. This is a nice simulation. This is kind of a trial, let's say. Only my simulations. All right, so nobody is doing something like this. There is no bone here, so I will not open it. No, please. This is a test. All right. They're using something nonlinear here for the titanium. Yeah, they are professional. Was in engineering. They're top experts, so I only expect the best from them. So nice cutouts. Yeah, very, very nice. What have they done recently? Oh, kind of a break. This is very nice. It was a lot of work. The modeling was a lot of work, the geometric modeling, then the simulation. This is like a trial, let's say. I don't like how the periodontal ligament is being crushed. It can be done better, but yeah, for a future simulation. Let's see if it's okay. It's a little better. They begin to fly away. Ah, yes, they begin to fly away. So what I will do for the next iterations, I will further increase the normal and the shear stress limit towards maybe 20 megapascals and 12 megapascals here. We do have results. Let's leave it 2 or 3 more minutes. The problem is also the mandible is flying away, so yeah, I'll work more on it offline. So I would say that this is all from my side at this moment. You have seen the trials, the struggle with the modeling, with the meshing, and applying proper boundary conditions and contacts. So feel free in the near future to access these files from my Patreon account, and you can do even greater things, even better than what I'm showing here. So this is a start, a beginning which it can be successfully continued. Ladies and gentlemen, this is all from my side, and all the best in your simulation endeavors. Bye-bye.